Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue my series on first-person graphics. Last video, we finished up talking about how to display the graphics, but I mentioned that the system that I was using to generate the environment was not very good, and in particular, because it was quite random, it often meant that the player was limited to a very small part of the environment, just because of where the walls happened to be. There was large parts of the environment that the player couldn't get to, and I wanted a system that didn't do that. I wanted a system that allowed the player to get to the whole, the whole environment. If I wanted a 100 by 100 environment, I want the player to be able to get to most of a 100 by 100 grid and not be limited to sort of 10 or 15 squares, say. So that was the first sort of need that I had. There are a lot of algorithms for creating mazes, or sometimes they call them labyrinths. Unfortunately, when I converted them to Twine code, it was very, very slow. A lot of them, in fact, caused errors because it was calling too many includes. If you call, I think, more than 1,000 or 100, I can't remember. If you call more than a certain number of include commands at the same time, that'll cause an error and the program will crash. Now that's fairly easy to get around because I could just use go-tos instead of includes, say, but that didn't stop the main problem, which was that they were very slow. So I wanted a system that was quick, and I did mention, I think, that I thought I was probably going to have to use a system which didn't generate the whole environment at once, but instead generated a little bit. So it would generate a small part of the environment, and then if you move to a new part that hasn't been generated yet, it'll generate that bit. And hopefully it would be able to do that without any noticeable lag. So I had sort of two needs, and as I was testing various ideas, either my own ideas or some that I found, I also encountered a third want, which was I didn't want long tunnels. And the reason for that is, let's say you have a wall here, here, and here ahead of you, and you have one here, here, and here, and you move forward, and you still have a wall here, here, and here, and here, here, and here. Well, nothing will change in the picture, so it won't be obvious that you've moved. And I found that quite frustrating. Sometimes I'd click and go, well, did I not move, or did I not click it properly, or have I moved and nothing's, I've just moved and nothing's changed. So that was a bit frustrating. Sometimes I'd sort of click it twice and then I'd move too far and so on. So yeah, I wanted a system. Ideally, this was probably less important than the other the other two wants, but I wanted a system that didn't create long tunnels. So I found a system that is reasonably good at all three of those things. First of all, let me show it to you. So we have so as you can see, there's no and you might notice it is a little bit repetitive, but there's a certain amount of variety. It's not like it's exactly repeating every time. And if you were to continue, to explore this, you would see that you are able to get to every part of the environment, whichever place you wanted to go to, you could get to, and as you can see, there aren't any long tunnels. So that minor need has been met as well. All right, so let me leave it there, and I'll show you a bit of the code. And then I'll sort of explain a bit more how it works. So you can see that we have the same 4 pages that we had in previous videos, at least if you've seen those videos. And so we've got initialize, outer wall, position, and display. Initialize just sets up the variables, names the variables, has notes about what everything does. Outer wall sets up, as you might expect, an outer wall, which we need because of how it tests squares to see what's there. Position just sets up the position for the player character. Display is sort of where you would spend most of your time when you were playing it. It displays what you can see, and it has the buttons that allow you to turn and move. And then we have a new page, which is create block. So I have set it up so that the environment is divided into repeating patterns, I suppose, of squares, which I call blocks. And when you go to a bit that hasn't been created yet, that's what this page does. It creates the new part of the environment. So let's look at initialize. There's a couple of new variables which are important. This is $A. It doesn't stand for anything. Usually my variables stand for something, but $A, I just called it that because I had $A and $B, and then as I was doing it further, I realized I didn't need $B. So $A is a 2-dimensional array, and it contains the basic shape of the environment, or the shape of the sort of the block that is repeated to make the environment. And the 1s and 0s mean the same thing as they mean in $M, which is the array that stores the contents of the environment, which is to say 0 is an open space and 1 is a wall. So we'll look at this pattern a little bit more, but first we have BX and BY, and that is how many blocks is the environment east to west, which is BX, and how many is it north to south. And then we have X and Y, which are the dimensions of the environment in terms of squares, but that is now a function of BX and BY. Instead, in previous versions of the program, I would just set a number, set X equals 20 or 10 or whatever it might be. But instead we have X equals 4 times BX plus 1, and Y equals 4 times BY plus 1. Now, if this is 5 by 5, as you can see that it is, you might go, well, shouldn't X be 5 times BX, not 4 times BX plus 1, and shouldn't BY similarly be 5 times BY? The answer is no, and the reason is because of this. Let's have a look at this. So imagine that this is the basic shape that is repeated throughout the environment. So imagine that the black squares are walls and the yellow squares are open space. And let's say you start, say, here, and you travel up here, and then it needs to create another bit of the environment. Well, it doesn't do this. It doesn't copy it like that. I could have done it like that, but I decided instead that they would overlap, and that's why it's 4 times the number of blocks plus 1. And similarly, like if you travel up here, let's say you go down here, well, now again it will overlap like that, and that that is the basic pattern that is repeated throughout the whole environment. And you can see that because there's, for each of them, there's exits north, south, west and east, well, obviously that means you can get everywhere. But there is a little bit of variety. Some of the, in fact, specifically half of the blocks have a wall either here, sorry, I'll click again, here, 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 or here, but only in one of them. So let's say that, for example, there's a block, there's a wall there. Well, that means that now in this block, you can't get directly from the southern end to the eastern end, but it doesn't mean that the southern end and the eastern end are cut off from each other. You can still go around, you can still sort of go around the long way. And similarly, if there's one up here, let's say, in this block, that doesn't cut anything off. You can still go from here and then go the long way around. So because of that, nothing in the environment is ever cut off. You can always, if you're here, you can always get down here. Whatever arrangement of blocks is in the way, you'll always be able to sort of get to the entire environment. And because of the layout, you don't get any long, in fact, you don't really get any tunnels. Wherever you look, there's sort of at most a couple of squares before you hit a wall. So that minor need is also met. All right, so let's get back to the code and let's see how it's done. So all this code I've already talked about. I'm using slightly different minor variables. I'm using x3 and y3 and x4 and y4 and x5 and y5. But yeah, we'll see that. They're pretty self-explanatory. We'll see them when we get to them. So outer wall works basically the same as it always did. Because this generates things as you go, there's no page where it generates the environment and then sends you to display. That'll be done sort of as you go here and here. So let's look at position. So you can see that what we do is we create a random number, and it's not any square. It is a random number from 0 to bx minus 1, then multiplied by 4 and add 1, and y1 does the same thing. So let's say we roll a 0, or roll. Let's say the random number generator gives it back a 0. Well, that'll be 1. It'll be 1, 5, 9, and so on, which means it'll be the same position in this in one of these blocks. It's always one of these. It's always the lower left corner. In fact, I'll make it clearer by getting rid of these colours. It's always generating the lower left-hand corner of a block. And the reason it's generating the lower left-hand corner of a block is because that's how create block works. Well, actually, you can see it on the notes. It says create a block whose lower left corner is x1, y1. So that's why we do that. We pick a random lower left corner, and we're going to generate a block with that as the lower left corner. And then we say x2 is x1 plus 2 and y2 is y1 plus 1. And that puts the player there, just south of the central block, but facing in a random direction, because instead of setting D to 1, I've set D to a random number from 1 to 4. So you'll always start at that part of the block, and it'll always have a single block will be created, and nothing else in the environment will have been created. So let's look at how create block works. And it's fairly simple once you've got once you've got this array, we have two for loops, x3 and y3. They go from 0 to 4, and we set m x1 plus x3, so the lower left-hand corner plus 0 to 4, and the y is the lower left-hand corner plus 0 to 4. We set that to be a x3, y3. So, for example, at the start, x3 will be 0, y3 will be 0. It'll set this slot in the M array to be A00, 0, which will be 1. Normally, I don't like starting from 0. So normally I would have gone from A1 to A5, and then I would have put a little something like this at the beginning, so that it's sort of started from 1. But in this case, using zeros is a bit easier. So I haven't done that. So all it does is it copies that pattern into M, with the lower left-hand corner being square x1, y1. And then, if random 1 to 2 equals 1, in other words, if there's a 50% chance that this slot in M will be 1. This looks a little bit more complicated than it is. It says M random 0 to 1 times 2 plus x1 plus 1. Well, random 0 to 1 times 2 means either 0 or 2. Plus 1 means either 1 or 3. So essentially this means either x1 plus 1 or x1 plus 3. And then this is laid out exactly the same. So this is either y1 plus 1 or y1 plus 3. So why is it plus 1 or plus 3? Well, because that's the lower left-hand corner. And if we add 1 and 1, we get that corner. If we add 3 and 1, we get that corner. If we add 3 and 3, we get this corner. And if we add 1 and 3, we get that corner. So that randomly picks one of these four corners to be set to a value of 1. In other words, to be turned into a wall. And so that sets up the starting situation, and we can go to display. And then we have to make sure that we have to see if the player is looking at any undefined squares, essentially. And if they are, we need to fill in those squares. We need to create another block in that part before we get into displaying it. So this code down here is all stuff we've talked about before. It's displaying what's in front of the character. But if what's in front of the character isn't defined, then we need to create it before we do that. So we need to define a few different pairs of variables. We have x1, y1, x1 and y1, x4 and y4, x5 and y5. x1 and y1 is the lower left corner of the new block that we'll be creating, if we're going to be creating one. x4 and y4 is the square directly in front of the character, and x5 and y5 is the square, two squares in front of the character. So we have one of these: if d equals 1, then do this, and if d equals 2, do this. If d equals 3, do this, and if d else, which means if d equals 4, do this, and then it gives instructions on how to define those variables. I don't know if there's a sort of fancy bit of maths that would have just done it in one equation. There probably is, but I couldn't work it out anyway. So I just had to sort of do it by hand. So let's go through one in detail. So we're facing north, and so remembering that x2 and y2 is our current position. So x1 and y1 is the lower corner of the new block. So that's x2 minus 2 and y2 plus 1. Well, why might it be x2 minus 2 and y2 plus 1? Well, I'll tell you why, and I'll have to jump around in the order a bit, but let me show you. This is the important thing. If these things are true, then that's when we're going to create a new block. So it's if m x5 y5 does not equal 0 and m x5 y5 does not equal 1. So what does that mean? Well, m, all of the slots in the two-dimensional M array, we only have values of 1, which means a wall, 0, which means open space, or undefined, which means we haven't got to it yet, basically. So there's no single way to say, or at least I don't know of an easy way anyway, to say if m x5 y5 is undefined. So the only way I could do it is to say if m x5 y5 does not equal 0 and m x5 y5 does not equal 1. In other words, if m x5 y5 is undefined, and x5 y5 is the square that is 2 squares in front of the character. So if the square 2 squares in front of the character is undefined, and the square that is 1 square in front of the character is open space, that's when we create a block. So why is that the test? Well, because let's say we are facing, let's turn this back into yellow so we've got just a basic block. Let's say we're facing south. Well, the square, 2 squares in front of the player character is going to be undefined if we're here, because then that'll be the 2 squares in front of them will be that one. If we're here, because then it'll be that one. Or if we're here, and then it's going to be that one. But we only want to create a block. If we're here, we don't need to create a block to the south yet, because we can't see anything down there. We only, out of these three, we only need to create a block, a new block, if we're here. So that's why we have that test of if the square 1 square in front of the character is open space, that's when we create a block. So if we're here looking south, it'll say, is the square 1 square in front of the character open space? Yes. Is the square 2 squares in front of the character undefined? Yes. Great, we'll create a new block. If we're here, then one of those things will be yes. The one in front of the 2 squares in front of the character will be undefined, but the one that's 1 square in front won't be open space. So therefore it won't. So that in conjunction with this basic shape, that test means that we will only create a new block if we're facing south here, or if we're facing east here, or if we're facing north here, or if we're facing west here. But what if we're here? You say, what if we're here and we need to create a block? Well, you always start here. You always start in one of those squares, which means that if you're facing south, you'll already have created a block. You'll create a block when you're there. By the time you get to this one, you won't need a new block. So that's why we have that specific test. And of course, there's a few things that could break that test, and we might have to go back to it and make it something different. If we had different shapes, different basic shapes, that test might not apply anymore. If we had a spell that moves the character to a random part of the dungeon, that might not work anymore. If we could teleport here without going through that square, then it might be that this test wouldn't work anymore. But for now, when you just move 1 square at a time, this test is fine. The test is basically saying, if you're here facing east, here facing south, here facing west, or here facing north, then that's when we know to start a new block. So let's look at one in detail. Let's look at facing south. We set x1 equals x2 minus 2, and we set y1 equals y2 minus 5. And that is the place where we're going to start the block, if indeed we do start it. So let's have a look at this and check that that's right. minus 2 would be over here, and minus 5 would be here, and that would be the lower left-hand corner of the new block. So that is the right square to be the lower left-hand corner. And then we set x4 equals x2 and y4 equals y2 minus 1. Well, that's the square directly in front of the player. And then we set x5 equals x2 and y5 equals y2 minus 2. And that's the square that is 2 squares in front of the player. And we do similar things with different directions. I won't go through all of them, but for example, if we're facing east, x1 is x2 plus 1 and y1 is y2 minus 2. So if we're here, it would be plus 1 and minus 2. And again, that would be the lower left-hand corner of the new block that we would draw. And so we have, of course, similar for if we're facing in the other directions. So if that's the case, then we go to create block, and we've already looked at create block. And then we move on to, there's quite a lot of code, but we've talked about this code before. This is just the code that gets the squares that are immediately in the player's vision, and then works out which pictures to display and displays them. And that's really all there is to it. It's just creating. It's waiting until we're in the right place, which is these 4 squares, and then if we're facing in the relevant direction, and if we're facing into a place that we haven't created yet. So if we were here and facing west, it wouldn't do it, but if we were here and facing south, it would. And then it just creates a new block, and again, it occasionally puts a little bit of variety, so it's not completely repeating itself. And that is how that works. It's not a completely ideal solution. It's certainly very quick, and I certainly haven't noticed any lag when it's creating new areas, and it seems to work. But it is a little bit repetitive. We probably would like to have slightly more variety. And in future videos, I'll be looking at ways that we can do that. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.